Stage 2. Idling. The job of the idling system is to keep the engine running at a low speed using the minimum fuel and air. The 1B and 2B carburetors differ at idling from the theoretical carburetor shown in Carburation, the Basic Principles, in that the throttle valve is closed at idle and there are two idling systems. Because the throttle is closed at idle, air cannot pass into the engine via the throttle valve. Therefore, another method of passing air into the engine is used. That is, by an air bypass channel. Hence the commonly used term, air bypass carburetors. The closed throttle valve and the air bypass channel are the secrets of these carburetors. At idle, with the throttle closed, the airspeed through the bypass channel is extremely high. The speed creates a very strong depression within the channel, which is used to obtain a very accurately metered fuel-air mixture from the idling jets. Note that if the throttle valve is open at idle or the engine has poor compression, the airspeed through the bypass channel will be slower and the idling system will not operate correctly. The idling system is in two parts, the basic idling system and the auxiliary idling system. Let's take a look at the basic system first. The depression in the inlet manifold and the very fast airspeed through the bypass drilling act on this drilling. This causes the higher atmospheric pressure to force fuel through the main jet and into the basic idling fuel jet. At the same time, atmospheric pressure will force air through the basic idling air jet, which mixes with the fuel at this point. The fuel-air mixture flows through the drilling and is controlled by the CO adjusting screw before entering the engine in front of the cut-off valve. The basic system, as the word suggests, caters for the basic fuel-air supply for idling. But don't forget that it also supplies the progression drillings. Now the auxiliary system. The addition of the auxiliary system allows for very accurate fuel-air adjustments to be made. The very fast airspeed passing the end of this tube creates an even stronger depression at this point, allowing the atmospheric pressure to force fuel through the main jet into the auxiliary idling fuel jet. Air enters the auxiliary idling air jet and once again mixes with the fuel. The fuel-air preparation passes along the drilling and is controlled by the idling speed adjusting screw before entering the engine in front of the cut-off valve. The amount of fuel-air preparation flowing into the engine from the auxiliary system is dependent upon the strength of the depression acting on the auxiliary emulsion tube here. To slow the idle speed, the idle screw is moved in. The airspeed through the bypass drilling slows down and the depression weakens at the auxiliary emulsion tube. As a result, less fuel-air preparation flows from the auxiliary system, weakening it. If the screw is moved out, then the reverse takes place. The system is enriched and the idle speed is increased. Note that after adjusting the idle speed, CO may change and should be corrected using the CO screw. The final item in the idling system is the electromagnetic cut-off valve. When the ignition is switched on, this valve is energized and opens the idling bypass channel. On switching off the engine, this valve de-energizes and closes the idling bypass channel, stopping any fuel-air mixture and thus preventing running on. The 2B carburetor has an additional fixed non-adjustable basic idling system for the second stage. This ensures a more even distribution of idling fuel-air preparation into the engine. This is where the jet is located, and this is where the fuel-air preparation leaves the carburetor. Any corrections for CO are carried out on the first stage CO screw. Now for idling adjustments. Firstly, all prerequisites should have been checked and corrected. Then the idling adjustments can commence. 1. The engine should be up to operating temperature. 70 degrees C. 2. All current consumers should be switched off. 3. The crankcase breather hose should be off and plugged on the air cleaner side. 4. The engine throttle valve is closed. See the workshop manual for the method. 5. Connect the tachometer and CO meter. 6. Set the idle speed for the particular vehicle. 7. Set the CO for the vehicle. If after adjusting the CO the idle speed changes, repeat steps 6 and 7. 8. Reconnect the crankcase breather hose. The CO may rise. Do not readjust it. On these carburettors then, we've seen that there are two idling systems to be considered. Having dealt with the adjustments of idling speed and CO, in the next section we'll look at what happens during the moving off sequence.